in the last class we have started the topic curve fitting. So given a discrete data, if you want to plot it, you will get a scattered plot like this. So given a discrete data, let's say x1, y1, x2, y2, likewise let's say xn, yn. And if you want to fit a straight line which goes through the given data, this is the equation. Here a and b are unknown. So if you want to fit a straight line through a given data, you need to compute two unknown, a and b. So to compute these two unknowns, we were solving these two normal equations. Similarly, given a data, if you want to fit a parabola whose equation is y is equal to ax square plus bx plus c. Here you have three unknowns. These are the normal equations. So if you have data in the form of x1 y1, x2 y2, xn yn, you can easily compute summation of xi, summation of yi, and all these quantities, summation of xi, yi, and so on. So once you compute all these numbers, you substitute those numbers into these three equations. So you will be having three linear equations in three unknowns, a, b, and c. And once you know a, b, and c, substitute that a, b, c over here, you will get the required desired equation for the parabola. So this is how we have solved two type of question. One, when you fit a straight line through a given data, and when you fit a parabola through a given data. So case 3 is when you fit an exponential curve through a given data. So in case 3, we are going to consider these two types of curve. As you can see, both are the exponential curves. So if you want to fit a data using this kind of curves, either this or this, how will you approach? See, here you have exponential. So what you can do is take log on both sides. If you take log on both sides, what will you get? Log y is equal to log a e bx. Similarly, this side log y is equal to log a b to the power x. So here you have to use a formula log m into n. You know that log m into n is equal to log m plus log n. So this formula we are going to use on the right hand side. If you use this formula, what will you get? So you are going to get log a plus log exponential bx, and here you are going to get log a plus log bx, correct? Now this you can again simplify using this. You must be knowing this. Log m to the power n is same as n log m, correct? So we are going to use this formula over here. So you will get log a plus bx log e, and log e is nothing but 1. Similarly, this side you will be getting log a plus x log b. Okay, so this is what you are going to get if you want to fit a curve of this form or this form into a discrete data. So ultimately what you have got, log y is equal to log a plus bx. For this type of curve, if you want to fit this type of curve into your given data, and this side you got log y is equal to log a plus x log b. Now what I will do, this I will write as capital Y is equal to a plus bx. I can do this. So here y is equal to log y, capital A is equal to log a. Here, okay, this is capital B. Capital B is equal to small b, capital X is equal to x. Okay, so here this is the case, and this side I will be writing y is equal to again a plus x b. Here you can see that y is equal to log y, this is capital X. Okay, so capital X is equal to, just compare, capital X is equal to small x and capital B is equal to log B. So this is the case. So finally in the case of exponential curve, you need to solve this type of equation, and you can figure it out that this equation is nothing but equation of a straight line. So finally you need to solve an equation for a straight line. So now let's solve some problems. So let us consider one problem. Fit an exponential curve of the form y is equal to a e to the power bx to the given data. This is the given data. X is given, y is given, and you want to fit a curve of this form into this data. So this is case number 1. Remember, y is equal to a e to the power bx. So to fit a data, you ultimately need to solve this equation. This equation y is equal to a plus bx. Remember, here capital Y is nothing but log y. A is log a. Capital B is nothing but b. Capital X is nothing but small x. But here this is nothing but your straight line. So you have to somehow use the normal equation for straight line, because you need to compute capital A and capital B. Correct? So what is the normal equation for a straight line? So here it is. If your straight line, the equation of the straight line is small y is equal to a plus bx, these are the equation. So here in that case, exponential wala case, it is capital Y, capital A, capital B and capital X. So what you have to do, you just need to replace this small y, small a, small x to capital. Okay. So normal equation for this curve, y is equal to capital A plus capital B plus capital into capital X are these. But here, remember, in your question, you are given the values for small x and small y. Remember, xi, yi means you have given the discrete data of this form. But here you require the discrete data, the summation, this value in the form of capital I. So what you have to do is, you need to first compute capital Yi, capital Y, capital Xi. Okay. So let's see what is the definition of capital Y in this case. So here it is. Capital Y is nothing but log Y. Capital A is nothing but log A. Capital X is nothing but small x. So these are the given data. What you need to compute? You need to compute capital Y first of all. And capital Y is log Y. So you have to compute log of 133, log of 55, log of 23, log of 7, log of 2, log of 2. Here we have computed capital Y, which is nothing but log of Y. Capital X into Y, that is nothing but small x into capital Y. So this is the values, you can cross check them. So this is log 133, it is 4.8903. Likewise, I have computed log of each and every of this is small yi. So since you have now all the data, all the required data, now we can use this equation, these normal equations, to compute capital A and capital B. So to substitute in the normal equations, you need summation of capital Xi, summation of capital Yi, summation of Xi, Yi and Xi square. So I have computed all these values and I have substituted these values into the normal equations. So I got this. And now you can easily compute the values of capital A and capital B using your calculator. So here you got capital Y is equal to A plus capital B X. But remember, we are not interested in this. In this case, we wanted to get a curve of this form, Y is equal to A e to the power bx. Okay. Remember, we wanted to have a curve of this form. So how will you get this? You just need to change capital A into small a, capital B into small b. So here, look at this. You had capital A is equal to log A and capital B is equal to small b. So you just need to use these two to get small a and small b. Once you know small a, small b, you are done. So you know that capital A is equal to log A. How will you compute small a? Small a will equal to e to the power capital A, correct? And small b is same as capital B. So capital B we have already computed. This is the value of capital B. So capital B and small b are the same. You just need to compute exponential of A. That is, you just need to compute e to the power. What is the value of capital A? 9.4436. You just need to compute this. And if you compute this using your calculator, I guess you will be getting 627.092. So your final answer is y is equal to a, that is 12627.092 e to the power bx, and b is, here it is, minus 0.9177x. So this is your final answer. Okay, and similarly, if you want to fit a curve of the form y is equal to abx, if you want to fit a curve of this form, you just need to solve y is equal to a plus bx, where y is equal to log y, a is equal to log a, and here it is, capital X is equal to small x, capital B is equal to small b. So you just need to use this data. Here is your homework problem. Fit a curve of the form y is equal to ab to the power x to the data. This data is given, small x and small y is given. Now using capital Y is equal to a plus bx, just fit the data.